So in this chapter, we want to deal with a radical signs here. When we make a change of variable, we can get rid of the radical sign and transfer the variable x into the space of sine and cosine or tangent. Okay. But remember, so originally we are computing the integral with respect to x. We need to find the corresponding limit in the new variable theta. So therefore, the angle should be, in order to do so, we need to have a one-to-one function so that we can take inverse of that. Okay? And these angles should satisfy this condition, as you can memorize here. If you define x to be a sine, then theta should be from negative pi over 2 to pi over 2. Similarly, if you define x to be a tan, then theta should be from negative pi over 2 to pi over 2. Similarly, if you face something like this, x squared minus a squared, then we should define x to be a secant theta. And in this case, some convention, the one-to-one function of sine secant inverse, we take from the angle from 0 to pi over 2 and from pi to 3 pi over 2. Go back to section 1.5 to review these things. Okay. And we have been doing the first example here. This is integral of square root of 9 minus x squared divided by x squared dx here. From this strategy, the table here, we know that we should define x sine theta, right? This is indefinite integral, so we don't have to change the limit here. That is nice. We have already go through this example, and here the relation between dx and d theta is given in this equation. We take derivative with respect to theta in both sides, right? The left-hand side is dx over d theta, and the right-hand side derivative of this with respect to theta gives us 3 cosine theta d. Therefore, we've been doing this. I believe that you've done this back home, and we got that integral of this becomes this guy. Okay. Previously, we know that integral is equal to negative cotangent theta minus theta. How can we find theta and cotangent theta, right? And this is a trick to do it fast, because we have the relation x is 3 sine theta. Therefore, the relation between x and theta can be written as this one. We know that sine theta. Suppose we have a special triangle whose hypotenuse is 1. Then sine theta is this angle, for example. Then the length of this edge will be x over 3, right? Because from this relation. Is it okay with this one? Yes.
Why would that whole side be x over 3 and sine like opposite the opposite side of x and
Yeah, that is okay. If you define it x here, and theta is here, and the hypotenuse is 3, it is fine. But these two triangles are similar, right? It is totally fine. If you do, okay, if you do like this, theta, this is x, this is 3, then this is fine. And what is the length of this edge here? This side? 9. minus x squared, right? Then cotangent will be very good. Thank you. Who was that? Thank you, Mia. So, and if you use this formula, yeah, the way you choose the triangles, it seems to be better. Yeah. If you do it this way, then the sign here will be 1 minus x over 3 squared, right? And it will give us the same result. But your choice is smaller corner. Yes, very good. Anyway, from this relation, we found that negative cotangent theta will be this guy, right? Negative of 9 minus x squared divided by x here minus theta here. Theta is, if we take sine inverse both sides, right? What do we have? Thank you. Inverse of sine x over 3 plus c, right? Sorry, it's kind of hard to see here. Let me write it down this way. Right, from this, we know that it is negative square root of 9 minus x squared divided by x minus sine inverse of x over 3 plus c, right? Where c is a constant or it is in R. Very good. That's it. Is it clear? Do you have any question? Very good. Now we know the trick, right? We know how to deal with this function. Let us try another example. Here is a note. You can look at the what I gave you a few days ago. I printed out and gave it to you already. Then, wait a minute a second, I'm off your. Okay. Here they explain that, okay, the trick, we draw the special triangle, will give us the relation between theta and x here. Yeah, it's just valid for theta is smaller than 0 as well. So finally, we have this relation. This is the result. Very good. And here, let us compute the second example here. Suppose we have the ellipse given by this equation, x squared over a squared plus y squared over b squared is equal to 1. Then this is the graph of this equation. Right, the graph of this is this guy. Okay? Because of symmetry, instead of computing the integral of computing the area of the whole ellipse, we can compute 1/4 of this in the first quadrant, the blue area here. Okay? That makes our problem simpler. So from this relation, if we subtract both sides by x squared over a squared, and we do some algebra, then multiply b squared both sides, right? We have y squared is b squared over a squared times a squared minus x squared, right? Then we take square root both sides, Okay. And we take square root. Remember that we need to take plus and minus. There are two possibility solution. Then we have y will be plus and minus of b over a square root of a square minus x squared here. Because we're trying to compute the simpler integral in the first quadrant only. In the first quadrant, the y equation here will have the positive sign here, which is the b over a square root of a squared minus x squared. And x goes from 0 to a here. Okay. Is it clear up to this point? Is it clear why we restrict ourselves to the first quadrant only? Very good. To make our problem simpler, instead of dividing two cases, right? Y is positive and negative. We take advantage of that properties, symmetry. So, therefore, this is a function y, right? The integral of this function from a 0 to a, from here to here, will give us the area under the curve. Is definition of integral, right? Take the integral with respect to dx. Therefore, we have this form. A and b here is simply, they are simply constants. So, can we rewrite the area as if we multiply for both sides and at the same time we take b over a out of the integral? It becomes this, right? Yes.
Aren't we just trying to solve the first one then?
Yes.
So do we only need a quarter of it, not multiple ones?
Yes, just a quarter of this. That is why.
Oh, we don't need to multiply by 4 then, right?
Yeah, in this, you're right. This is 1/4 a, and I just want to write the area in this way. Okay. Anyway, this guy is simply a constant. You can ignore it for now, right? The integral here, the difficult things is the radical sign. And by looking at the strategy we have seen before, we define x to be, yes, x will be a sine theta, right? From this relation, if we take derivative with respect to theta, both sides, it will be the same. And the right-hand side here, what is it? Yes. Very good. So, therefore, dx will be a cosine theta d theta. Okay? Now, we know dx, the relation between dx and d theta already. Very good. What should we do next? Any idea? Yeah, before doing that, we need to find the limit, right? This is the limit with respect to x. Then we need to find the limit with respect, thank you, Audrey. We need to find the corresponding limit with of theta. So at x is equal to 0, right? Therefore, if x is 0, then what do we have? 0, we substitute to this relation, right? We define here. It will be 0 is equal to a sine of theta. Therefore, sine theta will be simply 0. Okay? We have sine theta is equal to 0. In order to find theta, we take sine inverse both sides. The left-hand side gives us theta, right? The left-hand side gives us theta. What is sine inverse of theta? Very good. If you don't remember it, here is the unit circle. This is sine, it's not a good circle. Okay. This is the sine axis here. And inverse and the angle 0 will be at this point. Inverse of this give us, this is 1, this is -1, right? Inverse of 0 right here would be angle 0. The same story, okay? Now we need to find the relation of x and theta when x is equal to a here, right? When x is equal to a, what do we have? Replace x by a here, right? Very good. Then, therefore, what should we do? Yeah, divide both sides by a. Therefore, 1 will be sine theta. We take sine inverse both sides. Right, the right-hand side becomes theta. Okay. What is sine inverse of 1? Yes, very good. This point here, right? Therefore, pi over 2 is equal to theta, or you can write theta is pi over 2. Now, we know the relation already. So, the integral here, right? Let me add one more page here. A would be 4b over a, integral from 0 to a of square root of a squared minus x squared by dx here. So we will replace everything we know. 4, it is a number. B over a is a number. We write it. Now the limit. We just found it here, right? At x is equal to 0, theta will be 0. At x is equal to a, theta will be pi over 2. Okay? Now I do it. Thank you, Audrey, for reminding me. So, and here, this is a squared. We just rewrite it, right? And x squared. We have x is this guy, then x squared will be? Yes, it will be a squared sine squared theta And dx here, we just found it. Dx we replace by a cosine theta d theta. Is it clear? Replace, yeah, each of them by things we know. Do you have any question up to this point? Okay, this is simply a substitution, right? Therefore, we keep computing it. The number, we just rewrite it. This is integral from 0 to pi over 2. This guy is, what should we do? Yeah, we simplify it. Here, a is the common things, right? So we can factor it out. So what is left inside? 1 minus sine squared. And here we just rewrite a and cosine theta d theta. Okay? So square of a product, it will be, what do we have here? It will be the same as square root of a squared times square root of this guy will be, yes, very good. This guy, we just rewrite it. So a is a positive number, right? Square root of a would be a. And here, we take out of the square root something square here. It should be an absolute value. Cosine theta here, right? Okay. But in the first quadrant, theta, cosine of theta, is it positive or negative? Positive. So we can get rid of the absolute sign, right? Therefore, it will be 4. And the constant here, we can take it out of the integral, right? Would be b over a times a squared integral from 0 to pi over 2 here, cosine theta d theta. Okay. 4. And can we simplify this guy? Yes. 4ba. You comfortable with that? Okay. Okay. Here, what should we do? Which formula should we use? Yes, it is. Thank you. Go back to the trig formulas. Thank you, Conan. That is a good point. It is 1/2 1 plus. Yeah. Cosine 2 theta, right? Double check the formula for me. Plus, yeah. If it is sine square, then it should be a negative sign. So just memorize, please. Again, the constant number 2 here, you can take it out, and 4 times 1/2 give us 2ba. Very good. Here, this is integral from 0 to pi over 2 of 1 d theta plus 0 to pi over 2 of cosine 2 theta d theta, right? Then, what is it? 2BA, right? Integral of the constant, it will be, yeah, the difference one, it will be that constant multiplied with the difference of the limit. Or yeah, I understand what you mean. Okay, you want to find the antiderivative first, it's fine. Theta, very good. And antiderivative of cosine theta, cosine 2 theta, you can do substitution or you do it many times already, right? We know that it will be very good. Okay, and we take the, yeah, if I write it this way, this is theta is equal to 0, so theta is equal to pi over 2. Subtract this guy, or plus, right? Of the limit here, theta will be from 0 to theta is equal to pi over 2. And Luke have already mentioned that in class at the very beginning, that we can write it this way. It is the same thing. Theta plus 1/2 sine 2 theta, and the limit, we can do it this way. Okay. Just write it explicitly, you will see that it is not difficult to see. Okay, so we replace the value by the upper limit. And what do we have? Pi over 2 and be careful. This is 2 times theta. Yeah. Okay. Very good. But let us write it slowly. Oh, subtract here, right? 2BA. This is 0 plus 1/2 sine of 0, right? Sine of 0 is 0. This is sine of pi, give us 0 as well. And in the end, yeah, it will be yes, pi over 2, or it will be, okay, very good. Is it clear? Any questions so far? This is the whole fist. Yeah, you see, because we multiply both sides by 4 already. Or if you just compute this integral, and then in the end you divide it, you multiply by 4, it will give us the same result. Okay. Well, one question takes a lot of time, right? But we don't have to do many problems in class. We do one problems, but understand it deeply and understand every step. Then the other problems will be similar. Okay. So now let us summarize. Okay. Suppose, okay, let us do the example 3 here. Now the same story. The difficulty of this is the radical sign, right? So we need to get rid of this by using substitution. And look at the table, the strategy. What should we define here? Tangent, right? Because somehow it will be tangent square something. Okay, let us define. X is tangent theta. But is it good? What should we modify? 2, right? Because at the end we need to square here, therefore it should be 2. Very good. So the same story. Now we need to find the relation between the two variables. Okay. The derivative of the right hand side gives us secant square, right? Okay. Therefore, the relation between these two will be dx is 2 secant square theta d theta. Okay. It is an indefinite integral, so we don't have to make a change of the limits. Okay, it's nice. But in the end, we need, okay, let us replace and let us define this guy as I. Okay, therefore, I will be what is it? For tangent squared theta here. That is the first term, right? The second term here is 4 tangent square theta plus 4, right? Dx now we replace by this guy, it will be okay. We good? Then here, this problems, okay, let us simplify it and continue. Okay, imagine this is a fraction multiplied with another fraction. You can imagine that, okay? This is this divided by 1. Then the product of two fractions will be the numerator times numerator, denominator times denominator. Therefore, we can write it 2 secant square theta, right? And the denominator here will be 4 tan square theta. And if we factor 4 out, what do we have inside? Very good, 10 squared plus 1. And this guy, what is it? Secant squared. Good. So it is 4 times secant squared. And now we do it fast. We take it out of the radical sign, right? Okay. Remember, look at here. It is a note that theta should be from cosine should not be 0. Therefore, it would be from 0 to pi over 2 and from pi over from pi to 3 pi over 2. Remember it? Okay, this is very important. In these two, it is in the first and the third quadrant. Okay? What should we do? It's in the first quadrant. Oh, it is just secant. Okay? No. We define u to be tangent. That's what I confused myself. Yeah, I'm sorry about that. This angle is not correct. If we define secant, then it should be in that quadrant, this quadrant. But if we define tangent, yeah, sorry about this. That's why I feel a little weird. Sorry, it will be from, yes, my bad. So it will be in the first and the fourth quadrant. Okay, very good. In these two quadrants, cosine will be always positive, right? Cosine is positive and secant is 1 over cosine. Therefore, secant will always be positive in these two quadrants. It is positive, so we can get rid of the absolute sign. So are we good here? That is the reason we should do step by step. We cannot skip. Okay, good. So we have this guy. We remove the absolute sign. Perfect. Now we simplify it, right? The constant here with this guy. Oh no, the number 4 is still here. And secant, so it would be? Very good. Yeah. Okay, any suggestion? Cotangent. Yeah, thank you. Because in this form, 7.2, we don't see any quotient form of this. We should try to simplify the question somehow. Thank you, Angeline. Okay, very good. Thank you, Audrey. We change them into sine and cosine. The top here, can I write it this way? Secant is 1 over cosine theta divided by the denominator, and the denominator is sine squared. Are you comfortable with this, the way I write it here? I find that it is easier to explain. Okay, now division of two fractions. We can change. Yes, thank you, Aluk. It will be the multiplication. This guy multiply with the reciprocal of this guy. Okay? Just write it slowly. Then we simplify it, right? It becomes Thank you. Very good. Okay, what should we do? Yeah, we do substitution. Wow, it's complicated, right? U is sine or cosine, right? Let us try. So if we define, very good, thank you, Alex and Angelina, and yeah, it's make a sign. Thank you, Audrey. Yeah, Angelina contributed a very long idea. I couldn't hear it clearly, so but anyway, thank you. So here, if we define u to be sine theta, right? Then we need to find the relation between du and d theta. What is it? Okay, very nice. Right, this guy here. Okay, therefore, this is I, right? This is I. Therefore, I will be, we do 1/4. What is it? Yes. No, you're doing so well. Very good. Are we good? Perfect. So people on Zoom, is it clear for you? Okay, let us continue. What is the antiderivative of this guy? It is always easier to look at this way, right? U to the negative, u to the n, where n here is -2. The antiderivative of this guy would be u to the -2 and antiderivative. So we add 1 here, right? And remember to multiply with a fraction whose denominator is the same as this guy, which is -1, right? And remember, it is an indefinite integral. Okay, so it will be u/1, -1. Okay, very good, thank you, Alex. And so we found it in terms of u, right? Or you can write it 1/4 of 1/u, and u is sine theta, right? We just defined above. Therefore, we need to replace it by 1/4, 1/sine theta plus c, right? Where c is a number. Are we done? No, yeah, it's a long question, right? So remember here, we define x is 2 tan theta. Therefore, if theta is here, right? Oh, yeah. Oh, my bad. Thank you, Ava. Good catch. Yeah, sometimes we write. Yeah, it is a careless mistake. Okay. This is x/2 is tan theta, right? If this is x, then this should be 2. And what is the hypotenuse here? Very good, right? From this special triangle, what is sine of theta? Very good. So sine of theta is equal to this. Therefore, 1 over sine theta will flip, right? And it will be square root of x squared plus 4 over x. And we will replace it here. Okay? Sorry for taking 1 more minute. Q and class dismissed here. Yes. You can leave now. If you have more questions, I'm pleased to answer you.